All right. Hello, everybody, and welcome to Network Partners' Brunch and Learn Performance Testing Best Practices. A few quick housekeeping items. We ask that you mute yourselves upon entry. Note, a colleague and myself will actively monitor and manually mute participants as needed. Next, we ask that you please address all your questions through the chat feature of this platform. If you move your mouse around just a little bit, you'll see there's this little show conversation chat icon that you can click, and that's where you can insert your questions, and we'll do a Q&A at the end. We'll answer these questions, and then lastly, this webinar is recorded, and you will receive the recorded presentation as well as the PDF version of this PowerPoint. So without further ado, Network Partners' Technical Fellow, Dr. Jane Severin.
Good day to all, and thanks for joining us today for our discussion about medical device performance packaging. The objective, sorry about that. The objective of the discussion is to provide an overview of package performance testing and to touch on point of use. And by point of use, I don't mean usability testing, but rather the condition of the package when it arrives at the point of use with the practitioner. You may have heard it referred to as the last 100 yards or the last 100 feet or meters. So an outline of today's talk, we'll start with a very high-level overview of package performance testing, get into what the regulations currently say, what our current test practices are, and again, discuss the point of use, and then wrap up with some key takeaways. Design validation per 11607 includes usability testing, and verification includes package stability and package performance testing. As I said, today's webinar will focus on performance testing. Stability testing will be discussed in a few weeks on another webinar. And 11607 clearly states, per the note on this slide, that performance testing and stability testing are separate entities. The sterile barrier system serves three key functions. Number one, to allow for sterilization, which is why we select porous materials for the application of EO gas. Secondly, to maintain package integrity throughout the entire supply chain to the point of use with a practitioner. And thirdly, to facilitate aseptic presentation. Package performance testing is used to determine how a packaged product will perform under simulated environmental and distribution conditions. Properly run performance testing can provide for a timely or reduced time to launch, increase confidence in your system as it goes to market, reduce product damage in transit, and apply the appropriate level of packaging protection so you're not over packaging, and of course, customer satisfaction. So when we refer to package testing, what is a failure? In the case that you're not meeting your acceptance criteria for a package performance test, it might mean that you have to return to the drawing board, to the design phase. But in the field, the loss of package integrity can have very, very serious outcomes. It could cause a costly product recall, all the way to compromised patient safety. Sterility can't easily be measured, therefore package designs and processes must be validated and controlled. The SBS, or the sterile barrier system, is the first line of defense to infections during invasive surgeries. When the integrity is compromised, worst case again is that there's a risk of the patient may end up with an HAI or healthcare acquired infection. This can be very, very serious. It takes a huge toll on humans and finances. The CDC reports that there are approximately 1.5 million infections in the US per year and 75,000 deaths per year from HAIs. The WHO, World Health Organization, in Europe projects that, or 2014, that 500,000 people got a SSI, which cost the European system 19 billion euro. Per the CDC in the US, of million surgeries in a year, 1.5 million patients will get an HAI, which costs the system $10 billion US dollars. Certainly, these rates are not attributed to packaging, but packaging could play a role in this. We just don't know at this point. Making good material selections and designing appropriate packaging, which was discussed a few weeks ago in another one of our webinars, are critical steps to help maintain sterility of medical devices, again, until the point of use. Protect the device and ensure the labeling is affixed and legible at the point of use, and to support the regulatory compliance process, considering the new requirements of the EU MDR and ISO 11607-219. So let's review what the regulations do say. We'll cover 11607, QSR 820, and EU MDR. ISO 11607 Part 1, 2019 addresses materials and design. In section 6.17, maintenance of sterile barrier integrity may be used to demonstrate the maintenance of sterility. 6.16 states that a terminally sterile barrier system with its protective packaging, and by the way, protective packaging is defined as configurations of materials designed to prevent damage to the SPS and its contents from the time of their assembly to the point of use. If protective packaging is included, it shall be designed to maintain sterility through exposure to expected conditions and hazards during the specified life, processing, storage, handling, and distribution until the SPS is again opened at the point of use or until the expiry date. The GMP for medical devices, Part 820, 1.130, Subpart K, called Labeling and Packaging Control, states that the device packaging and any shipping container for a device shall be designed and constructed to protect the device from alteration or damage during the customary conditions of processing, storage, handling, and distribution. The EU MDR states that devices shall be designed, manufactured, and packaged in such a way that their characteristics and performance during their intended use are not adversely affected during transport and storage. For example, through fluctuation of temperature and humidity, taking account of the instructions and information for use provided by the manufacturer. The EU MDR also states that the maintenance of sterility shall be ensured until the packaging is opened at, again, the point of use. The EU MDR goes into effect on May 26, 2021, so you must comply by then to maintain your CE mark. And again, through all of these regulations, we see point of use being used frequently. Currently, we perform testing per the first four gray boxes, from the MDM, the medical device manufacturer, to the sterilizer, to a distribution center if applicable, and then on to the customer. While some manufacturers may be testing to the point of use, it is not typically performed. It is also important to note, if your validated case is broken down at the distribution center, you are no longer validated. The current standards utilized, which are considered consensus standards by the FDA, are ASTM D4169, D7386, and ISTA 3A, B, and E. For 11607, it recognizes and includes in the appendix the same standards minus 3E and plus ISTA 4A and B. It's important to note that ISTA 2 series is no longer included or recognized. This will not be accepted anymore as a performance test. There's a lot of pre-work that has to be done before you conduct a performance test per one of these standards. Before testing, you should understand and characterize your distribution environment. That means get involved with your distribution, your warehouse people, and really understand what your package is seeing out in the environment, both from a physical input as well as atmospheric. Choose the best test method that best meets your needs. Conduct a risk assessment per your company procedures to determine your sample size requirements. Define worst case in terms of sterilization, weight, geometry, pack factor, etc. There was a webinar that was conducted a few weeks ago that did a great job of defining what worst case is. So if you're interested in that, I'd recommend looking that up on our website. Label samples extensively, numbers, location, etc. So in the event, if you do have a failure, knowing exactly where the sample was in the box, on the pallet, etc., will help with your root cause analysis. Validate your test methods. It's no longer can you adopt a standard and call it validated. You must validate your own test methods. This is an outline for an FMEA. There's many, many ways to do an FMEA and many, many ways to do a risk assessment. To highlight on this one in particular, there's a populated with a line with the failure mode being damage to the SBS during shipment. The effect possibly being harm to the patient and the cause handling, as we discussed before. You rank the severity, probability of occurrence, and ability to detect and multiply to obtain a score. And again, there's many ways to do this. Per your company procedure, this may require that you achieve a 95% confidence and a 95% reliability. Here is one equation of many used to determine sample size, with C as confidence level and R as reliability. The sample size is calculated approximately 59 for attribute testing when testing worst case materials. And again, I know that question comes up a lot about sample size, and this is just one way to arrive at that. This is a slide directly from ISTA.org, and I included it because often in the industry you'll hear performance testing called shake, rattle, and roll, or shake and bake, or something to that effect. This chart includes all the testing that can constitute a major test category. For example, vibration includes fixed displacement, variable displacement, and random, with all subtests under those. So designing the best test for your product can be more complicated than most may think. In preparation for performance testing, the test product is preconditioned to prescribed temperature and humidity levels. This is important as common packaging materials such as paper and plastic, their properties can be impacted by these inputs. Thermal shock is an issue as well that we hear a lot about. This should be addressed in this element as well. This element has been confused in the past with accelerated aging. This, of course, is not accurate. Accelerated aging is its own entity. Shock evaluates the ability of the packaging system and product to withstand drops and collisions. Vibration testing is important because vibration occurs in all forms of transportation. It is complex and can intensify the natural frequencies within a system. Often the question comes up, how much time should I vibrate my product for? And it's in ISTA 3B and E, I believe, there's a formula for correlation of vibration time to test time, which is very helpful, but it is not a one-to-one relationship. If you consider that thousands of field measurements and compilations go into developing a PSD, or pyrospectral density profile, which allows in a condensed period of time to test your product and simulate all forms of vibration in the distribution environment. Other test elements include compression, altitude, which is applicable to non-porous packaging, and simulates reduced air pressure experienced in higher elevations. It's important to remember that altitude exposure in a truck can exceed that of a commercial flight. And finally, impact testing, which simulates some types of shock that could occur in the handling of packages or shipping units. It's important to note that per ASTM 4169, D4169, subpart J, that this is only applicable to shipping containers under 275 pound or 44 ECT. Here's a chart comparing the elements of D4169 distribution cycle 13 assurance level 2 and ISTA 3A. You will see that they are very similar with the exception of the top load vibration included in 3A. This is not included, this is a dynamic top load. This is not included in 4169, but is included in ASTM D7386. Question often comes up on which one is used more, D4169 or ISTA 3A. My impression with talking with a lot of people and talking with a number of laboratories that it's a pretty even split. If you had to pick one that's used more often, probably ASTM has a slight edge. Again, sterility can't easily be measured. Therefore, package designs and processes must be validated and controlled. In a sense, the performance testing we discussed is a conditioning event, and the integrity test methods employed to determine acceptance criteria are the true tests. There are numerous examples of integrity testing, but the three most common are visual, per ASTM F1886, which has a sensitivity of 75 micron. Internal pressurization bubble test per F2096, which has a sensitivity of 250 micron. And finally, the third most common is dye penetration per ASTM F1929, which has a sensitivity of 50 micron and is only for measuring defects in the seal area. So we've completed our overview of performance testing. So I'm going to close out with some discussion of point of use or the last 100 yards. You know, is the hospital a dirty place? Do we know how our packages are handled once they leave the shipping dock? This chart is a result of a literature search that was intended to find out the contamination in hospitals. And so the axis on the left is country in the world, and across the top is actual area in the hospital. And this data is very difficult to get at because hospitals tend to keep that close to the vest. But you can see while there's wide ranges across the different areas and the different countries, it definitely is a contaminated place. It's a dirty place. And it's measured in colony forming units. I didn't mention that. So colony forming unit is where one microbe reproduces into a colony. This slide talks about the pathogen survival rate. It can survive for some length of time on dry surfaces. You can see that MRSA is up to 9 months, where staph pyogenes up to 6.5 months. They're not reproducing at this time, but are dormant. But when they are nourished again with a moist environment, they can begin again to reproduce. So this is something that we need to be aware of. This chart talks about the settling of in still or turbulent air of contaminants and particulates. And again, it's based on mass. Viruses at the smallest, being the smallest at 0.015 micron to 0.5 micron, can be in the air for up to 41 hours approximately. Bacteria, the mid-size between a half micron and 10 micron, can be in the air anywhere from 12 hours to 8.2 minutes. And then skin cells, human skin cells, the largest at 10 micron, can settle out in 8.2 minutes down to 5.8 seconds. These are some pictures that I discreetly took walking through a hospital, and the intent is just to show how rough the hospital environment can be for our packages. Here you see a bunch of different types of packages stuffed into a plastic basin, and I question, is this something that we're testing for? Is this something that we should look into? Here's a common way of storage, and this is a stainless steel cart, and they have little subsections for storage of different types of packages. And you can see here that in some of these bins, the packages have been just stuffed in there, which can cause flexing and unwanted damage and breach of integrity. The other thing to remember on these carts is that they have burrs on them, stainless steel burrs, which can wreak havoc on a package if it's run across that burr. Here's the rubber banding unitization, which you see frequently, but is not a recommended way to store packages. It causes flexing and again might result in unwanted damage or breach of integrity. So I guess the questions I want to leave you with when discussing point of use testing is, are we currently qualifying for this type of handling? Is it part of our current overall test schemes? And then most importantly, do we need to test for this? I encourage you, if you're interested in these industry discussions, to join or be involved in ASTM FO2 or D10, where these discussions have taken place, or Kilmer Innovations in Packaging, which is starting a team that's going to be discussing this important topic. I've included the LinkedIn address if you're interested in learning more about that. So the key takeaways for today's talk is, number one, understand your distribution environment to the point of use. This is really important that you do so. Number two, understand the risks associated with your packaging system. And again, there's numerous ways to do risk assessments to understand what your particular risks are. Define worst case for your packaging system. And finally, apply this and construct a meaningful package performance test. So that concludes the webinar for today. Renee?
Yeah, thank you so much for this informative presentation. We're going to migrate over to the Q&A now. I had to go ahead and scroll up. So the first question is, can you discuss the business case of recommending ISO 11607?
The business case of recommending ISO 11607, it's a requirement. It's so that the business case is that you need to follow the requirements set forth by the various regulatory agencies. So I'm not sure, I'm really not sure what that question is getting at, but
Sure. So we also have Lon on the line. Lon, are you able to speak to this?
Yeah, I believe so. Hi, everybody. My name is Lon Goldbaum. I'm the Senior Director of Packaging Engineering for Network Partners. Just to kind of build on what Jane just said, really, if you're working in supporting with terminally sterilized medical devices, the benchmark ISO standards that you want to follow that need to be compliant with are ISO 11607 Part 1, which covers your packaging, design, development, performance, stability, aseptic, and usability presentations. From that standpoint, and also Part 2 of the standard, which covers your process validation, so like IQ, OQ, PQ with the equipment, the materials. So those are requirements in order to for regulatory submissions.
Okay, great. Thank you. What would you consider worst case sterilization for package performance testing?
well, if it's within your process to, for example, to do 2 times EO sterilization, that there's a chance that the product will be re-sterilized, then your worst case would be 2 times sterilization, EO. And as far as the range of kilograys for gamma sterilization, you'd want to do the highest amount of kilograys for your worst case package testing.
Can concentrated impact test be eliminated by reducing packaging size? In other words, making the package smaller?
As far as I know at this point, the exclusion of that is containers under 275 pound or 44 ECT. I could be wrong, but I'm not aware of a size limitation on that.
Hi, Jen. Noel Gibbons here. Yeah, you're correct there. That it's dependent on the material in the actual shipper box that's being used, not the actual size.
Thanks, Noel.
Okay. How should the assurance level be determined?
Your assurance level is arrived at by conducting a risk assessment. A very high risk device such as an implantable or a very high cost device may fall into the category of assurance level 1. Typically, and is also stated in the standard ASTM 4169, assurance level 2 is the default. But again, your risk assessment will dictate which assurance level you should be using.
Great, thank you. So Jane, as you approach point of use testing discussions, is it being motivated by industry, regulatory agency, or is it the manufacturer concerns with consumer safety?
I think primarily it's all three, but I think primarily it's the industry questioning as new regulations come out and point of use is used much more frequently than it has been in the past. I think it's the industry that's really questioning this and discussing it, and will ultimately determine if it's something that we need to incorporate into our current test methods.
Okay, back to 11607. A follow-up to that very first question: why do we have to comply when we didn't have to before?
I think I can field that. So really, I'll put it to you this way: you really don't have to comply to 11607. That's only if you really want to commercialize product and start selling in Europe and make sure it's safe and effective. So the ISO standard allows us with a certain set of requirements, because if you look at the FDA guidance, it's very generic, high level. This provides all the details that we need to fully verify and validate that your packaging and your process and your design are safe and effective to the point of use.
All right. 11607 and FDA recognize both ASTM D4169 and ISTA 3A. Hypothetical scenario: you test same systems to both methods, pass 3A, fail 4169. How would this scenario be handled?
Well, it'd be unusual, I think, to run both tests in parallel. But if you don't, regardless of which one you're using, if you don't pass your acceptance criteria, that's clearly a failure that has to be addressed with understanding the root cause and determining how to remedy that problem. But if you failed one and passed the other, you still have to go through that root cause analysis.
Okay, great, thank you. For EO, if production product can see 2 cycles, then is there any way to get away with doing one worst case EO cycle, worst case temperature, humidity, evacuation time, etc.?
If you can rationalize that, but typically if your product is going to see 2x, if the process allows your product to see 2x, that is what you would determine to be worst case. But again, if you can justify adequately, that may be something you could do.
And
Great,
Jane,
thank
may
you.
I jump in? I just want to jump in
Sure.
with that question too. So just to build on what Jane said, the other reason I use 2x ETO, because there's really nothing that says worst case ETO sterilization, right? What I've seen in the past is you validate your sterilization cycle and you can get a half cycle. It could fault somehow. So if your validations or verification studies between the device and the package aren't qualified for 2x ETO, you're going to end up scrapping that entire product load in the sterilizer, which obviously that's time and money, right? So you want to plan these activities up front. So you want to have it very concise planning for this. So as you go through this, yeah, it's best practice, I would say, to do 2x ETO for your performance testing, your stability testing, and your device functionality testing. That way, all the data is the same. So if something does happen, you get a short cycle, or the sterilizer fails for whatever reason, which it does happen from time to time, you know your product's qualified for one more run through it.
Okay, great. Thanks for expanding on that. How should we better assess sample size C and R targets with the understanding that both D4169 and ISTA3A have the 95 to 99 percentile of possible worst case distribution events? Can sample size be reduced or C and R targets inflated?
CNR targets. Lon, are you familiar with that?
Actually, I'm not. Maybe if there's a further discussion on what the intent of that means. Oh, confidence and reliability. So is this in relation to picking out, associating your confidence reliability level with your sample size? That's my understanding.
Yeah.
Okay. Yeah, and I think as we all do, right, we get our sample sizes based on severities or the risk priority number from your FMEAs, your risk documentation, right? And that kind of dictates your sample size. The way I've done it in the past in many validations is, 95% confidence, 95% reliability, which I believe equates to a sample size of 58. Usually we round up to 60 anyways. But based on that, what further involved with that would mean for attribute testing, because typically attribute testing is a sample size of 398 or 298 and 598, which is something that's a lot of resource commitment there. So what we would say is we would evaluate the whole system under worst case circumstances. So what does that mean? Wes Bush gave a great webinar prior to this one on defining worst case. So worst case geometries, mass, pack factors, even down to the seals, all the seals, like your supplier seals and the MDM manufactured seals, so you get worst case seal strength. So you know that you're testing based on this sample size of 58, that it's going through worst case, everything, and you can prove that out at the end that it still maintains sterile barrier integrity and what it's supposed to do.
All right, thank you. Is it true that you need to perform all of seal strength, seal integrity, whole package strength, and whole package integrity?
To conduct all of them, not necessarily. It's good practice to conduct at least two in addition to visual. But all of them, not necessarily, but at least two. Bubble immersion or dye testing.
What is the first step you would take to understand the risks associated with your package system?
Well, in conducting an FMEA, I would start with, the damage or the problem with the package being breach in integrity, and then look at all the things that might cause that. Something in the environment, something in the handling environment that might cause a seal defect, such as altitude or sterilization where creep may occur. So it'd be identifying the failure mode and then all the aspects and all the elements that might cause that to occur. And then from there, you define the severity or the probability of occurrence and ease of detection. But I would start with what the possible failure mode may be.
All right, and we are down to our last question, at least as of now. Oh, no, sorry, there's going to be a few more. How the acceptance criteria regarding defect size is set up? So how is the acceptance criteria regarding defect size set up, and why is it 50 UM?
50 micron. That's based on within the standard at ASTM, for example, they do precision and reliability testing to determine what the sensitivity is of the method. So that's those numbers that I read off, the sensitivity numbers, 50 micron being for the dye testing, and 250 micron for the bubble immersion, and the 75 micron for the visual.
Okay. In your answers on sample size, are your sample size N for the number of shippers or for the individual sales unit cartons in a shipper?
That's a topic of a lot of discussion over the years. My opinion on that is the number of saleable units within the case. So the number of devices versus the number of cases. And I know that's been discussed a great deal in the past, and there's a lot of people that strongly believe that that number should be the number of cases. But as a matter of practicality, sometimes more than anything, it defaults to the number of devices.
Great, that was a good one. I mean, they're all good, obviously, right? But do you suggest peel open and seal transfer visual inspection after other package tests? Do you include seal width measurement?
Yes, I would include seal width measurement. It's important to set your acceptance criteria for minimum seal width and include that in your evaluation.
Yeah, and I would say, add to what Jane was just saying, is like when you go through the ISO standard, and it helps to have a checklist, you do have to meet these requirements. And if you don't, for whatever reason, meet these requirements, there are some options in there. You should have a very solid technical rationale as to why you haven't, there wasn't a need to do that.
All right, great. And then we're down to our last question, and that is, do auditors look for data?
Yes, in my experience with auditors, they do look at data for not for everything, but for they may select a certain validation protocol, and they do look at your data. They look at it completely, including your data. That's been my experience.
All right, great. Thank you so much, Jane, for this. Sorry, I saw another bubble pop up. Okay, I believe we're good. So thank you everybody for your participation today during this Brunch and Learn, and to our speaker, Dr. Jane Severin. If you have any packaging questions or need further help, you can always reach out to a Network Partners team member, and we can ensure that it gets to the appropriate contact. A couple times during this presentation, it was mentioned that there were historical webinars that were referenced, and Network Partners now offers all of those previously recorded webinars on demand under the resources section of networkpartners.com. There you can also register for upcoming live webinars. Again, you'll receive this recorded presentation and the PDF of the PowerPoint itself. Be sure to stay in the loop and follow Network Partners on LinkedIn to access our updates and our future free webinars. Thank you again, and have a great rest of your Thursday.
Thanks, everybody.